Right, this is lesson 11 of module 5. This is the last lesson in the module, and we're going to talk about volume of a sphere. In the last lesson, we covered prisms and cylinders and cones, and so now we're going to look at spheres, which are also interesting. And so here's some pictures of different spheres. You kind of know what they are, but maybe pause the video right now and see if you can think of a mathematical definition of a sphere. Okay, so to mathematically define a sphere, we just have to think of any point in space, and I'll label it right here, which is going to be the center of our sphere. And then the sphere is the collection of points that's a given distance from that center point. And so here's our center point. So all of these points that are on the sphere in three-dimensional space. So if it was just a circle, it would be a two-dimensional, all the points that are a certain distance, also called the radius, from a certain point. But for a sphere, we're three-dimensional space, so we can go all over and around, and that's your sphere. So really, it's a shell, if you think about it. So if you're going to find the volume of it, it's the capacity that it would hold inside of that shell. Okay, and so like we did in the last lesson, we want to relate this formula for the volume of a sphere to something else that we know. So again, in this case, we're gonna relate it to a cylinder. Okay, and so we've got this cylinder here, and it has a sphere in it that is large as it can be and still fit inside the cylinder. Okay, so the math that proves how these two volumes are related, this sphere and this cylinder, is pretty advanced math. So that's something that you would do in calculus. The other volume formula is the same way. But we can kind of experimentally verify it. And so I'm placing a video in the playlist that will walk you through filling this cylinder up. Obviously, the sphere has a smaller volume, so it's some fraction of the full cylinder. So like we did in class with cones and cylinders and also pyramids and prisms, we saw that those were 1/3 the volume. So maybe make a guess of what you think this sphere, how the sphere would relate to the entire cylinder. Would it be 1/3, 1/2? What would it be? And so think about that, and then watch the YouTube video that reveals the actual fraction of a volume that the sphere is to this cylinder. Okay? All right, so hopefully you have watched the video, but the volume, whoops, I gotta get my right tool here. The wrong color. The volume of this sphere is equal to 2/3 the volume of, I'll just write it out, the volume of the cylinder with the same radius. Same radius. And the height of the sphere. Okay, so you notice here that this sphere, because the radius is r, the base of the cylinder has radius of r. But also because the radius is r, the height of the cylinder has height of 2r. So that's the cylinder we're talking about. And the volume of that sphere in there is 2/3 the volume of that cylinder that is around it. Okay. So let's just talk through these exercises. So, let's see. So what is the volume of a cylinder? Specifically, what is the volume of this cylinder here? So the volume is, remember, 1/3. Not 1/3, sorry. We're on cylinders now, not cones. The volume is the area of the base times the height. So let's write that. Area of the base times the height. So the volume, the area of the base is pi r squared. And times h. So volume is pi r squared times h. And the height of the cylinder here is twice the radius of the sphere. So the height of this cylinder is 2r. Okay, so let's look down on number 3. If the volume of the sphere is equal to 2/3 the volume of the cylinder with the same diameter and height, what is the formula for the volume of a sphere? So let's work it out. So the volume of this sphere is, well, that doesn't look like sphere, but you know what I'm talking about. The volume of the sphere is 2/3 of the volume of this cylinder here. And the volume of this cylinder is pi r squared times the height, which I know is 2r times 2r. Okay, so we've got 2/3 times pi r squared times 2r. And what we want to do is just sort of straighten that out and multiply things. We can multiply and put things together. So what I notice is I've got everything here being multiplied together. And because I have the commutative property, I know that I can do these things, I can rearrange them. So I want to rearrange a couple things here. So this is equal to, I've got 2/3 times 2, which is 4/3. Let's get rid of that. So I've got 4/3 times, and that takes both of these constants, right? 4/3 times pi. And now I've got r squared times r. So that's r cubed. So the volume of the sphere is 4/3 pi r cubed. Okay, so even though it filled the cylinder 2/3 of the way up, remember the cylinder has a height. The cylinder has to have a double height from the sphere. So the height is 2r on that cylinder. Okay, so works out to 4/3 pi r cubed. So if all I have is a sphere, like this one here, then I know, if I know the radius, I can find the volume. 4/3 pi times the radius cubed. Okay. Okay, so now we're asked to compute the exact volume for the sphere shown below. And once again, we're going to express our answers in terms of pi unless we're asked to use an approximation for pi and get just a purely numeric answer there. So let's look at this. So we want to remember the volume of a sphere is 4/3 pi times the radius cubed. 4/3 pi times the radius cubed. So we have the radius given of 4 centimeters. So I can put that in. V equals 4/3 pi times 4 cubed. And I'll, just to make it really, really clear, I'll put that on there even though I don't have to. Okay, so let's just rewrite this again. 4/3 pi. Now, 4 cubed is 4 times 4, which is 16, times 4, which is 64. So this is pi times 64. And the only thing left to do is multiply the 4/3 times the 64. So I can do 4 times 64. You can use a calculator on these, but it's pretty quick to do them off to the side. So the volume is 256 over 3 pi. And that's an exact answer, and that's using in terms of pi. And I can simplify it down a little bit more. It would be 85 1/3, 85 1/3 times pi. So either of those would be acceptable answers. Okay, now we have a cylinder that has a diameter of 16 inches and a height of 14. So a diameter of 16 and a height of 14. And we're asked, what is the volume of the largest sphere that will fit into the cylinder? Okay, so the sphere can have up to a radius of 8 inches there. And then if you take into account the height, which is twice the radius, you find that the most that the radius can be in the vertical direction is 7, which would be half of 14. So going this way, if I have a diameter of 16, it's not going to fit in here. So we're going to need to use the smallest of the two. So the largest sphere that will fit into the cylinder would have a radius of 7 inches. Okay, so we're asked to find the volume of this sphere. So we've determined that it has a radius of 7 inches. So its volume is going to equal 4/3 pi times the radius cubed. 4/3 pi r cubed. So we could use a calculator on this to find out that this would be equal to 4/3 pi times 243. Then if we simplify that out, we're going to see that the volume is equal to 1,372 thirds. Times pi. So my volume, I'm running out of room, so I'm going to write it up here. If I put that into a mixed number, I'm going to get 457 1/3 times pi. And the units on that would be, looks like inches. Does it say inches there? Yes. So this would be inches cubed. Let's go back and make sure we put units on everything that needed units. So this one I forgot. So centimeters, we did r cubed right here. So this was actually 4 centimeters. So this whole number would be centimeters cubed. Okay, I did forget the volume. Okay, and that's unitless. All right, so let's continue. I actually want to make sure that we got inches cubed on the answer for that one. So there we go. Okay, now we can go on. All right, so you can work on exercises 4 through 8 on your own and just coming back and checking your work briefly. So go ahead and work on that with somebody else or by yourself. And we'll be back in a minute. Okay, so for this first one, we've got 4/3 pi r cubed is the general formula. Our radius here is 6 inches. So volume is 4/3 pi times 6 cubed. So we know 6 squared is 36. So all we have to do is multiply by 6 to get 6 cubed. Okay, so we've got, and then we're going to have 4, 6, 7, 8, 9. Actually, that divides. Okay, so we've got the volume, I'm working my way towards it, is 4/3 times 216, and we'll put that over 1, times pi. All right, I'm going to take a 3 out of here. This is 72, and then 4 times 72 is 288. So our volume here, V, is equal to 288, and they would be inches cubed. 288 cubic inches there. Okay, let's look at the next one. The average basketball has a diameter of 9.5 inches. What is the volume of an average basketball? And we're asked this time, we're asked to round our answers to the nearest tenths place. So we're still working in terms of pi here, but we're going to round to the tenths place. Okay, so what do we know about this sphere? Notice we've been told the diameter. That's really important to notice. So what is the radius then? The radius of the average basketball would be half of that. So it'd be 4.5 plus a little bit, so 4.75. And these are, what units do we have? Inches here? Yeah, inches. Sorry. Okay, so that's that, and so we can write a expression for the volume. So the volume is equal to 4/3 pi, and then 4.75 squared. Okay, so I don't really want to do all that with the calculator, so I will just tell you the answer, and you can check yours against it. So I've got 142.9 pi. Okay, so hopefully you caught me. That should be cubed right there. 4/3 pi r cubed. Okay, so 142.9 pi. All right, for this next one, it's again just a description. A spherical fish tank has a radius of 8 inches. Assume the entire tank could be filled with water. What would the volume of the tank be? Whoops. What would the volume of the tank be? And again, we're asked to round our answer to the tenths place. So all we have here is that it's a sphere, and all we need to know is how much it will hold. And we know that the radius is 8 inches. So we're going to use our formula, 4/3 pi times the radius cubed. The radius here is 8 inches. So the volume is 4/3 pi times 8 cubed. Okay, and this is 512. 512. So now we want to straighten it out. And looks like we're just going to be multiplying everything out and rounding the answer to the tenths place. We don't need fractions for this answer. So the volume, let's make sure we get units all the way through, inches cubed. So the volume is equal to 4/3. No, we're going to multiply it. We're going to multiply the 4/3 times the 512, and we'll get 682.7. And I still have pi, and I still have inches cubed. Okay, so that's the solution to the fish tank problem. So now you're asked to predict which of these figures would have the greater volume. So you have a cone and a sphere, and so you want to compare the radius there and figure out which one you think would have the greater volume, and then just give a brief explanation for why you think that. Okay, and then on the next page, we're going to calculate their volumes. So take just a minute to do that. Okay, so for the cone, the volume is going to be, remember, 1/3 times the area of the base, pi r squared, times the height of the cone. So we can put in the values that we have. 1/3 pi. The radius of the cone is 2.5 millimeters. And I'm going to leave the units off, and we'll put them on in the end. 2.5 is the radius, and then the height was 12.6. So we're going to be multiplying those numbers. 1/3 pi times 2.5 squared times 12.6. All right, so put that all in. I would do the 2.5 squared times the 12.6 and then divide by 3. And we'll get 26.25 pi. We're leaving pi because we haven't been told not to, okay? So that's the volume of the cone. So now what's the volume of the sphere? We'll put sphere up there. Sphere. So the volume of the sphere, remember, is 4/3 pi. Whoops. 4/3 pi times the radius cubed. And the radius we're working with on this one is 2.8 millimeters. So our volume is equal to 4/3 pi times 2.8 cubed. Okay, once again, it's a calculator problem. We're going to take 2.8 cubed, so times itself, 3 used as a factor 3 times 4 divided by 3. I wish I could show you on my calculator, but I'm going to take it out to enough digits so we can compare these. We've got 29 and, whoops, looks like we'll just round it to hundredths again, and 27 hundredths pi. Okay, so now we can see that the volume of the sphere was greater, given those dimensions. And I'm not sure they were entirely drawn to scale. Doesn't look like they were. So be careful of that. All right, if you thought the cone was bigger, they weren't drawn to scale. All right, one more. Let's look at number 8. One of 2 half spheres formed by a plane through the spheres. One of 2 half spheres formed by a plane through the sphere's center is called a hemisphere. What is the volume? What is the formula for the volume of a hemisphere? Okay, so what that sentence was saying was just that we want to take a sphere and kind of slice it in half. If you think of the Earth being a sphere, you'd be slicing it right through the equator. Okay, so what would be the formula for a hemisphere? Well, for the volume of a hemisphere, the volume of a hemisphere would be half, right? We don't even have to prove that. Would equal half the volume of the sphere with the same radius. Okay, so the volume of our hemisphere is going to be 1/2 times 4/3 pi r cubed. Okay, so 1/2 of 4/3 is 2/3. So the volume of this hemisphere is 2/3 pi times the radius cubed. Okay, so here's the summary for this lesson. The formula to find the volume for a sphere is related to the right circular cylinder. And we saw that when we did that, we came out with the formula for the sphere of volume, V, is equal to 4/3 pi r cubed. Okay, and so if we want to use function language with this, we would say the volume is a function of the radius. The volume of a sphere is a function of the radius. And this is the function here. So it depends on the size of the radius, obviously. Okay, so good luck with the exit ticket and problem set and the end of module assessment.